Hi viewers, welcome again to our series on fluvial processes and products. For this quick video, we'll be looking at traction, saltation, and suspension deposits. These are typically, different classes of deposits associated with fluvial sedimentation processes. Okay, so by way of uh, beginning, by way of start, we will just look at, just imagine a typical, you know, grain size profile where you have a coarse ones, the very gravelly components, and then you have the very coarse and coarse grain sizes, and then followed by fine and very fine sands, and then muddy components. So we're just thinking of this in terms of grain size, in terms of um, depositional energy. So the key point here is that the gravelly ones are the ones that travel at a much slower speed. They usually creep or roll on the surface of that's below the river, right? And then we have another group of grain sizes that move in jumps, small jumps, and those are called the saltation um, deposits. So the heaviest travel by traction. Those are the ones that creep on the surface. The other group of grain size are by saltation. Those are the ones that move in small jumps or small hops. And then we have the much lighter one that are usually suspended in the mass of water. So if I imagine, let's just imagine a profile. This, um, this is upstream, this is downstream, right? And then the river is kind of flowing in this direction. So sediments are kind of moving downstream, right? Um, that's the surface of the water up there. So typically what that means is that as you go downstream, of course, velocity is bound to increase. However, as a result of little bumps that you see on the surface, which I tried to address that in an earlier episode that talked about ripples. Yeah, and those are typically, if I'm going to sketch these small ridges that you see, um, you know, on the surface of just below the surface of the water. And those small ridges act as little bumps, and they act as barriers or velocity breakers. So if I have, a bunch of sediments, coming downstream this way in this direction, it hits a barrier. What happens? It slows down the mass of everything that is on its way downstream, and that causes the heavier ones, the traction components, when they go past this ripple, they get deposited first because they are quite heavy, and that's followed by the saltation components, and those are the ones that travel in hops. They literally just go in small cycles or small jumps, basically. Those are the saltation deposits. So they are light enough to be carried in pulses or in repeated episodes by the energy of the flowing water, but not light enough to be suspended within the mass of water. At the same time, not heavy enough to roll on the surface as creep or as traction deposits. So those are the saltation components, and then we have the lighter version, the lighter particles that are just kind of mixed with water as suspension and sometimes as solution um, deposits. So if I'm going to, let me just see if I can additionally represent this message in a way that is easier to understand. So if I just imagine, let's say, a mass of deposit coming, let's say 100%, mass of deposits coming downhill, and of that 100%, let's say 40% of it are suspension, or rather are very fine sands, or clay to very fine sand, and then another, let's say 40% are fine to coarse sands, and then you have coarse grain sand, and then you have, let's say, 10% of it are coarse to very coarse, let's say very coarse, grain sizes, and then the remaining 10%, let's assume they're just gravelly sizes. What that means is that as you're moving downhill, these bumps or these small breakers or ripples or small ridges that we have in the surface, or rather at the bottom of this water, will actually cause, as the sediments are traveling the direction from upstream to downstream, the heavier ones, the gravelly ones, this barrier will reduce the velocity of the whole medium, and it will cause the heavier gravelly components to be deposited first. And then as you progress, you have the very coarse ones follow suit, because they're still able to travel a little further out, but this time they move in small jumps, and that's why they're called saltation deposits or saltation sediments. And then you at the same time you also have another group that are very fine, that are light enough to actually just remain suspended, and those are the suspension deposits. So let's look at a quick video. Hopefully that will also help with the messaging. So as you watch this video, try and pay attention to the different grain sizes or different particle sizes. Also, try and observe the direction of movement. I mean, that should be the first one actually. I think by now you have a hint that this is current flowing in the direction downstream to your left and upstream to your right, either because of slope primarily, and also it could be enhanced or influenced by wind direction also. So in this case, you see the river moving from left, right, from our right to our left. Okay, and of course you can see the particles moving in that direction. If I pause for a minute, what you'll see if you focus on just this area, little area, this crescent shaped feature, this is the direction of travel of the currents of the river. Okay, so if you recall when we talked about these ripples, we also did say that particles moving in this direction are eroded from this side, from the store side, and deposited on the lee side. So what that means is that everything you're seeing here, these darker areas, these are heavy gravelly or pebbly grain sizes. They're all in this area, that's in the lee side or the slip face of this substrate, right? And then the finer grain components that are able to make it further out, that's the you can argue that those are the saltation components. They travel further out in mini jumps. Okay, so here I will have the traction, and then further out I will have repeated portions of of the saltation components, because they're able to travel further out. And then the suspension components are still just within the mass of water. So I'm going to let's just continue watching the videos, and hopefully there'll be more to learn from this. Okay. So you also notice that there are some particles that are moving at much higher speed, and if you recall, those are lighter in weight, and they are traveling again further distance than the heavier ones, which by their weight, because of their weights, they are unable to travel far away, and they just roll on the surface. If just again for another minute, if we pause this, you will again notice that everything you have in this area are not really moving away from there. They just, if at all, they just look at particle like this, another like this, another like that. These particles are just there. Just maybe when you have a very strong energy, they move a little bit, they just roll on the surface, they creep on the surface, but again, at the same time, you can also observe that there are other particles that are just at high speed going across that feature and going beyond this area in green, in red, and making it all the way out to this other area and then further out even. And those are the lighter components, and those are the ones that are able to be carried by that river strength or current velocity. But the heavier ones, these darker ones, are unable to make that distance. And just by way of information, some of those lighter components, especially the ones that are dark, and some light colored particles that are traveling at high speed, are generally micaceous minerals, because this area is close to some schistose rocks, and we have those flaky components making their way to the river and being carried by the current of water. So that's what you see. If I pause this again, you see some of these components right here. You see some of these, different particles that have been broken off the host rock, and then carried downstream in this direction. These are the heavier ones that are unable to travel far, but the lighter ones, you can also notice that they're making it all the way out. So that's about it for this session. I do hope you got some nuggets from it. If you have any question, please don't hesitate to reach out to us. Send me an email or put a note on our YouTube or Facebook page. We'll be sure to respond, and then let's get the discussion going. But this is generally what it is. Energy being a driver for how far these particles travel. The heavier ones, traveling a shorter distance, rolling on the surface as traction deposits, creeping on the surface. The lighter ones are traveling further out, in sometimes in jumps, sometimes all the way across, and those are the saltation deposits. And then we also have the suspension components that are just kind of more of the very fine grain to the clay components that are just there as suspension within the mass of water, which visually we can't see, but if you subject this area to much quieter energy conditions, you will see them settle out as more muddy or clay components. So yeah, so I do hope that you found this useful. If you do have questions, please reach out to us, and let's have a chat on this. Thank you very much for your time, and until next time, please have a good stay. Thank you.